Let's draw the map of knowledge for solid mechanics so that we always know where are we standing when studying the different sessions. Here, these 5 blocks represent the main pieces that solid mechanics consists of: kinematics, transition of force, materials model, load and boundary conditions, and governing equation. With the information of these 5 aspects, an engineering problem can be transformed to a mathematical problem. In fact, among these blocks, kinematics, transition of force, materials model, and governing equation can be big topics themselves with many subtopics. And we will touch upon each of them in this series of courses. Let's expand these blocks further. In finding solution of a problem in solid mechanics, we need a way to record the changing shape or geometry of deformation. This falls into the study of kinematics. Particularly for flexible bodies, we use strain to represent the deformation of material excluding rigid body motion. In this course, we will discuss the general idea of strain and also strain for small deformation and large deformation problems. The topics in this course are marked with stars on this map. The transition of force is essential to the equilibrium of the body. Stress is the measure of force transmission in the interior of continuous bodies. We assume that every piece of a body must be equilibrium, and equilibrium is derived from the balance of internal force. Tractions are forces that act on the surface of a body. When dealing with contact, we can deem contact force as a traction applied on an exposed surface of a body. Move to the next. The idea that force and deformation are related is intuitive. We have the strain to describe the deformation and stress to describe the internal force. However, the relationship between stress and strain is missing. Different materials have different stress-strain relationship, and we call such relationship materials model. It is a mathematical relationship between material deformation and internal force. Materials model is a big topic. The relationship can be assumed as simple as a straight line, or it can be a complex mathematical expression. Discussion of materials model will appear in the following courses. With kinematics, stress and equilibrium, materials model, and load and boundary condition, the statement of a problem in solid mechanics is completed. We're ready to solve the problem. The most general governing equation for solid mechanics is the equation of motion for deformable solids, which follows Newton's second law of motion. With certain assumptions, it can be simplified or transformed to different forms to address different types of analysis. For example, the equation of motion can be simplified to a static problem when neglecting the dynamic effect. As for dynamic analysis, it can be categorized to frequency domain problem and time domain problem. Both of them will be introduced in this course. There are so many different aspects to learn in solid mechanics. Through this series of courses, if you're lost in the knowledge in any sessions, you can go back to the map here to find where it belongs to.